So I'm showing you an illustration here. This is number 12, exercise 12 from your textbook. And this is going to be a sigma unknown scenario, because typically we're going to be using the sample standard deviation. Anytime you're using sigma unknown, it's always going to be the sample standard deviation. You never know the population. So it says the U.S. dairy industry wants to estimate the mean yearly milk consumption. They took a sample of 16, so n is equal to 16. That's our sample size. The average from the sample was 60, so x bar is equal to 60. And S is going to be equal to 20. So notice I didn't write sigma, I wrote S because this is a sample standard deviation. So assume the population distribution is normal. So to answer a couple questions here, part A says, what is the value of the population mean? Well, since we do not know the population mean, we can only approximate it. And so the way you approximate it is you just use your sample mean. So x bar is equal to 60. That would be our estimate of the population mean. Part B says, explain why we would need to use the t-distribution. Well, a couple things is, first of all, the sample size is small. Anytime you have small sample sizes, typically the t-distribution table usually factors in concepts and accounts for variables for skewness and small sample sizes, and therefore we have to make the assumption that even though it's a small sample size, we're going to be using the t-table. Our assumptions are still that the bell-shaped curve or the normal curve is what our distribution will look like. Okay, everything has to be that assumption in these problems, or we can't work it. Okay, so to actually do the data now in part C, it says for a 90% confidence interval. So 90% is our confidence interval. They want to know the value of t. So remember what you need to know to get a t value. I showed this earlier. Is we need degrees of freedom. And degrees of freedom is going to be 15. Remember, that's n minus 1. So if I go down here to my table, I got 90%. I'm looking for degrees of freedom of 15. And I see a value that says 1.753. So my t value is 1.753. So now to do the formula is x bar plus or minus your t value multiplied by S over the square root of n. So if 60 is my sample mean, plus or minus, we just figured out the t value, which is 1.753. We're going to multiply that by 20 divided by the square root of 16. Okay? And so essentially, once you plug all that in, you're going to get, of course, remember this part represents your margin of error. And then you add or subtract that from 60, you're going to wind up with an interval that's right at about 51 point, let's say 24, all the way up to about a 68. This is, again, rounding it off, 0.77, okay? Which basically means if I were to draw my curve and say I want to have a 90% interval, the lower data point will be this 51.24. The upper data point will be the 68.77. And you're saying basically you're 90% confident this is where all the values fall. Or you could also say 90% of all values should fall between these two numbers. Or you could also say, what's the probability that all variables of people consuming milk consumption will fall between these two values? You'd say that probability is 90%. And so then when they ask you the question in letter E, would it be reasonable to conclude that the population mean is 63 gallons? Well, look, 63 is in this range, so you could say it's reasonable because it definitely falls within this range. So again, this is an illustration on how to use the t-table. Remember, it's using this sample standard deviation is when you know you have to use the t-distribution table.